Welcome to The Explainer. Today, we're going to pull back the curtain on the hidden engine of the internet, the protocol that makes a web page appear almost instantly after you click.
I mean, have you ever really thought about it? What actually happens in that split second? It feels like magic, right? Well, it's not magic. It's actually a process that's been tweaked and perfected for over 30 years. It's the story of how a really simple set of rules had to grow up fast as the web exploded in complexity.
So let's get right into it. At its heart, HTTP is just the official language of the web. It's how your browser, Chrome, Safari, whatever you use, has a conversation with a server somewhere out there. It's like your browser says, "Hey, can I please see this website?" And the server says, "Sure thing, here you go." That little back and forth is the handshake that kicks off everything you do online.
So check out this journey. This isn't just some boring list of version numbers. No way. This is basically a map of the web's biggest growing pains. Each new version you see here was created to fix a massive problem that the old one couldn't handle, all in the quest to give us the super fast, media-rich, on-the-go web we pretty much take for granted today.
All right, let's rewind. Way back. We're going to start at the very beginning, a time when the web looked nothing like it does today. It was, well, a whole lot simpler.
And when I say simple, I mean incredibly simple. I'm not kidding. The very first version of HTTP was basically a one-trick pony. It had one job: use one command, get, to grab one HTML file. That's it. We're talking no images, no fancy formatting, no status codes, just raw plain text. It was the absolute bare minimum to get a document from point A to point B.
Yeah, you can probably guess what happened next, right? This super simple system created a huge traffic jam. The second people wanted to do more than just share text documents, like, add an image or two, this one thing at a time approach just fell apart. It was slow, it was clunky, and it just wasn't going to cut it for a growing web.
Okay, so along comes HTTP/1.1, and it brought a brilliant fix: persistent connections. This was huge. Instead of opening a new connection for every single little file, the browser could now keep one connection open and just ask for everything it needed all at once. A total game changer for speed. But, as is so often the case, solving one problem created a brand new and pretty tricky one.
Which leads us right to the next big headache for the early internet.
So here's the catch. Even with that faster persistent connection, HTTP/1.1 had a major flaw. It treated every request like a line at the grocery store with only one cashier. First come, first served, a strict queue. You can just think of it as a single-lane highway. Now, what happens on a single-lane highway if a big, slow truck gets in front? Exactly. Everyone behind it is stuck. That's precisely what happened on websites. A giant, slow-loading image could be that truck, and all the small, quick-to-load text files would just be stuck waiting behind it. We've all felt this pain, staring at a half-loaded page. And that phenomenon, my friends, has a name: head-of-line blocking. And to make matters just a little bit worse, the system running underneath all this, a protocol called TCP, had its own built-in delay. Before any data could be sent, it had to do this formal three-step handshake, like a secret password exchange. It's quick, but those milliseconds add up. This really just shows why keeping that connection open was so critical, and why that head-of-line traffic jam was such a performance killer.
So, how did the web's engineers finally blow up this digital traffic jam? Well, that brings us to the next major leap forward.
Enter HTTP/2. Now, this wasn't just a minor tune-up. It was a fundamental redesign, a total overhaul inspired by an experimental protocol from Google called Spady. It took all the best ideas from Spady, things like multiplexing, and baked them right into the official standard for the whole internet. The single goal? To make the web feel instantaneous.
And the absolute star of the show was multiplexing. This is the magic that finally killed head-of-line blocking. Remember that single-lane highway? Multiplexing turned it into a multi-lane superhighway. Now, that big, slow image can chug along in the right lane, while all the speedy little text files can just zip past it in the other lanes. Nothing gets held up anymore.
But HTTP/2 wasn't just about speed. It was also a massive win for security. And here's a cool little fact. The official rulebook didn't actually require encryption. But all the big players, Google, Mozilla, Apple, they all basically said, you know what? We're only going to support this new protocol if it's running over a secure, encrypted HTTPS connection. And just like that, they made the entire web a whole lot safer, pretty much by default. So, problem solved, right? We've got our superhighway. Well, not quite.
Just as we fixed the speed problem, a new one popped up. Our lives moved from desktop computers plugged into the wall to smartphones bouncing between spotty Wi-Fi and cellular data. And this created a whole new kind of challenge that even our shiny new Superhighway wasn't built for.
See that old, reliable protocol we mentioned, TCP? It's been the foundation of the internet forever, but it's rigid. It hates change. So when your phone switches from your home Wi-Fi to the cell network as you walk out the door, TCP just freaks out. It panics, drops the entire connection, and forces you to start that whole slow handshake process all over again. Not ideal for streaming music, right?
So this forced a radical change in thinking. A good way to think about TCP is like sending certified mail. You get delivery confirmation, you know it got there, it's super reliable, but it's also kind of slow. For our modern mobile world, engineers started looking at its sibling, UDP. UDP is more like dropping a postcard in the mailbox. It's incredibly fast, you just fire and forget. But you have no idea if it actually got there. The billion-dollar question was, how do you get the speed of a postcard with the reliability of certified mail?
And the answer to that question is a protocol called QUIC. Think of it as the best of both worlds. It's built on top of that super fast, flexible UDP, but it cleverly adds back in all the reliability features of TCP, just in a much smarter, more efficient way. And this is the engine that powers HTTP/3.
So what does this actually mean for you in the real world? It's simple. With QUIC, that moment you walk out your front door and your phone drops Wi-Fi and jumps onto cellular. You don't even notice. Your connection doesn't die, it just seamlessly switches over. Your Spotify doesn't stutter, your YouTube video doesn't buffer, it just keeps going. That's the magic of QUIC.
Okay, so we've been through a whole bunch of versions and acronyms. TCP, QUIC, HTTP/2. So why does any of this tech alphabet soup actually matter to you?
I think this quote really nails it. This whole story, it's not just about engineers making code faster for the sake of it. It's about the internet's very foundation evolving to meet our changing needs. It's about solving the problems that came up as we went from sharing simple text documents to streaming 4K movies on our phones.
Every single time you load a web page in a fraction of a second, every time your connection stays solid when you leave a coffee shop, every secure transaction you make, that is all built on the shoulders of decades of this kind of problem solving. It's the incredible, invisible engineering that makes the web feel so effortless and just work.
Which, of course, leads to the big question. We've solved for speed. We've solved for mobility. So, what's next? What new challenge will force us to invent HTTP/4? Will it be the mind-bogglingly complex, low-latency demands of a true metaverse? Or maybe the constant, real-time data streams needed for advanced AI? Or is it something we can't even picture yet? One thing's for sure. This story is a long way from being over.